All right, so we're going to move into talking a little bit about number, and that's going to be what the rest of the course is focusing on. And we're going to start very simple. We're going to talk about counting, just regular old counting. Start with 0, what's one more than 0? 1, and then one more is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it can go on forever. But something changes, especially you can imagine teaching somebody new to count and they see these symbols and they're like, all right, this symbol means one thing, this symbol means two things, etc. But when you get to 10, you could imagine somebody asking, well, why do we write it like that? It's not a new symbol, it's a combination of two symbols we've already seen. A 0 and then a 1 on the left of it. So why do we write it like that? Well, I think it's pretty obvious or pretty intuitive that we can't have an infinite number of symbols because there are infinitely many numbers, and that just wouldn't work. So we have to start reusing symbols. So what's going on here is we can use the idea of what place these digits are in one of these numbers to represent loads of different things. So in some sense, all we need are a finite number of digits. And in fact, we're going to use these symbols or digits here. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 different digits, 10 different symbols. And we can put those together, of course, to represent any number we like. And how does this work? Well, the whole idea is that we were just adding 1 to each number as we go. And when we get 10 of something, if we add 1 to 9, we get 10, of course. But to represent that, what we're going to do is we're going to add 1 to the next place value. We're going to introduce an extra digit here in this case. So 9 plus 1 is 10. So we're going to group those together into 1 10. So we can draw it out, in fact, with some dots. So here are my 9 dots. And then I'm adding an extra 1. But hey, look. Now, instead of having 9 dots, 9 dots plus an extra dot, I can say, well, I can regroup these in 10. So I'm going to make one long piece of 10 ones. And I'm going to call it a 10. So now I have 1 10 and no ones. I'm taking these 10 ones and I'm grouping them together to make 1 10. So this place here tells me how many ones I have. In the number 10, I have 0 ones. And then the next place over is, of course, the tens place. It tells me how many tens I have. The number 11, well, if I look at this with the same idea, I have 1 1 and 1 10. So I can draw that. Here is my 1 10 made up of 10 ones, and then 1 1 for 11 in total. But the whole idea is, anytime we can group things into 10 of that, we do it and we carry it over to the next place value. Well, the same thing happens with, say, let's keep going. I'm going to put some dots just to say we're going on. Let's say if we go from 99 to 100. Well, what's 99? So just for the interest of time, I'm going to write these tens as just lines like this. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 tens. That's this here, 9 tens. And then I'll do the ones in blue. And I have 9 1. So that's what this number represents, 99. 9 tenths and 9 ones. If I add 1 to it, well, let's do that. There is my extra 1. Well, now if we look here, I'll do this in a couple of stages just to see how it goes. But we have 10 ones now. So I can regroup these. I'll put a box around it and an arrow. I can regroup these into an additional 10. So now I don't have any ones left. I regrouped them. Maybe I'll color in what I've regrouped. I'll do it in blue, I guess. So I regrouped all that to make the one where the arrow goes to. So now I have 10 tens. But if I have 10 of something, I can always regroup them. So I'm going to take these 10 tens and I'm going to regroup them into 100. So now I have 1, 2. Let me draw that a little bit better. My 100 a little bit bigger so it's easier to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 tens here. Each of these tens is made up of 10 ones. So I have 10 times 10 is 100 ones in this. But I represent this as I have one of these squares, so one of these hundreds, no tens, and no ones. So this here is, of course, my hundreds place. And the idea is, of course, similar. And of course, if you regroup, if you have something like, let's do it like this. If you have 10 hundreds, you can regroup that into, of course, so let's regroup that. You can regroup that into 1,000. And the 1,000 is, of course, made up of 10 hundreds. Let me see if I can draw this. So there's one of those squares, second square, the third square, fourth, fifth, sixth, seventh, eighth, ninth, and 10th square. So you can think of them, I'm stacking them together. Here's the first square. You can imagine that's the left end of this cube, and here's the next one, and there's all 10 of them. I know the drawing isn't the best. I'm not the best artist, but hopefully you can imagine that we're taking these squares, and we're taking 10 of them together to make one cube. And we, of course, write that as 1,000. Here's your thousands place. So nothing particularly difficult about this yet, but of course we're just seeing where this is all coming from. Now, for better or worse, we have to stop drawing figures at this point. And the reason is, you can think of a 1 being a 0-dimensional object, because it's just a point. It doesn't have length or width or whatever. A 10 just has one dimension. It has, say, a length. It doesn't really have a width. 100 is a 2-dimensional object. It has a length and a width. 1,000 is a 3-dimensional object. It has a length, a width, and a depth. So it has 3 dimensions. So if I take 10 of these guys and I group them together, 10 of these thousands, I'll get a 10,000. But there's no nice way of putting them because it'll be a 4-dimensional object in some sense, and we can't envision 4 dimensions very well. Our brains are really only equipped for 3 dimensions. So at this point we have to stop with the analogy of figures, but the same idea holds. We take 10 of a previous place value and group them together to get another place value to the left. And of course, let's just write down a few of these. I think everybody's pretty good with these. If I have a number 2,349,704, well, this is saying I have 4 ones, no tens, 700s, 9,000s, 4 10,000s, 3 100,000s, and 2 millions. So I can write this in expanded form, if you like, as 2 millions plus 300,000, or sorry, 3, I have a comma there, I don't want a comma, so this comma should be a multiplication. I have 300,000s, I have 4 10,000s, I have 9 1,000s, or 9 cubes, I have 7 squares, I have no 10, so I'm not even going to write it down, and I have 4 ones. So that's the expanded form of the number 2,349,704. All right. When we write down numbers, we use the following digits, of course, 0 through 9. How many digits are there? There are 10 digits. You can count them. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And since there are 10 digits, we say that these numbers are in base 10 because we're using 10 digits to represent our numbers. Why do we use 10 digits? What's so special about 10? And the answer is there's nothing really that special about it. Back in the day, when people started thinking about counting and writing numbers down, we picked base 10 most likely because we have 10 fingers, and that's how we thought. So that's the reason we picked having 10 digits, or the reason a lot of people think we picked as a culture to have 10 digits. But there's nothing special about having 10 digits. It's a good exercise, and we're going to play around with this, of writing numbers in different bases. What if we had, say, fewer digits or more digits? What would that look like? I do want to point out a special digit that's really important is, of course, this 0 digit, because it's really important to be able to write down a way of saying you have nothing of a certain idea. So having that 0 in your digit set is incredibly, incredibly important. So let's look at something other than base 10. So other bases. Maybe let's look at something along the lines of base 6. What are the digits going to be for base 6? Well, we need a 0, and we'll have 1, 2, 3, 4, and 5. You can count, they are 6 digits. And the whole idea is that whenever we get 6 of something, that's when we regroup. In base 10, the way we usually write down numbers, it's not till we get 10 of something that we regroup. Let's explore this a little bit. I'm going to write down some numbers in base 10 and base 6, and then some blocks in some sense, and we'll explore how they look a little bit differently writing the numbers in each base. So in base 10, let's do 0, I don't need commas, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And we can represent these as blocks, of course. So 1 is just 1, 1, 2 are 2 ones, this is 3 ones, 4 ones, 5 ones, 6 ones. Remember, we keep them separate until we have 10 of something, and then we regroup. So here is 7, 8, 9, and now with 10, this tells us we have 110. I'll just draw a line there. That is 10 ones put together to make 110. And we have no ones. And 11 is 110 and 1 1. So imagine that there are 10 ones made that are used to make this 110. So this is 11 in total, 110 and 1 1. Well, how would we write these in base 6? So let's look at that. Let's do it in black, I guess. It's going to look a little differently. Well, the same number of blocks, no blocks, we're going to represent the same way. We're still going to have ones, and we have no ones here. 1 1 is still going to look like a 1. 2 ones is still a 2. 3 ones is a 3. 4 ones is a 4. 5 ones is a 5. But once I add an additional 1, I have 6 ones. So remember, the rule for base 6 is we regroup when you have 6 of something. So here, and it's going to look a little weird, but I'm going to write this number 6 in base 6 the following way. I'm going to write it as 1 0. So I'm going to take these 6 ones and I'm going to regroup them as 1 6. So this here is these 6 ones put together to make 1 long piece. The same idea with this long piece, but instead of 6 ones put together, there's 10 ones. Of course, because we're in base 10. So this is 1 6. And this is now in base 6. This is our 6th place value. So this is telling us we have 1 6 and no ones. So if we add an additional 1, well, to represent 7 in base 6, it looks like this, 1 1, where we have 1 6. Remember, these are now made up of 6 ones because we're in base 6. So we have 1 6 and 1 1, and that is, of course, 7 in total. 8 in base 6 is 1 2, so that looks like that. 9 is 1 3. We're taking 6 ones, grouping them, and then we have 3 left over. 10 is 1 4. 11 is 1 5. Let's draw them. So there's 1 4. Here's 1 5. And maybe let's do 12 as well. I'm just going to squeeze it in here. 12. So 12, of course, in base 10 is 1 10 and 2 ones. But in base 6, well, if I add another 1 here, I'm going to have 6 ones. I already have 5. If I have another 1, then I'm going to have 6 ones. So if I add 1 and then I regroup, I now have 2 6s and no 1s left over. So I can represent in base 6, I can represent 12 as 2 0. So it looks kind of weird, but hopefully you kind of understand the idea. Instead of regrouping in 10s, we're regrouping in 6s. And again, there's nothing particularly special about 6. We could do this with any number of digits we like. But let's do a little example just to make sure you guys understand what's happening here. So I'd like you guys to do the following. Answer what are the next 3 numbers base 6. And I will say it gets kind of confusing when you have a bunch of different bases around. I didn't do it up here when we were first talking about the concept, but from now on, whenever I write a number that's not in base 10, I'm going to tell you the base as a little subscript down the bottom of the number. So let's say if we have, let's do 5, 0, 5, 1. What are the next 3 numbers? And what if we start at, let's do 2, 4, 2, 5, and I should write down the base here. I'm going to write it down in blue. So we're in base 6, so I'm going to put a little subscript of 6 in all of them to say that that's what we're doing. What are the next 3 numbers? And then let's do 5, 4 base 6, 5, 5 base 6. What are the next 3 numbers? So, using the ideas above, see if you can fill in the blanks. Pause the video now and try to do it. It's a good idea to try and draw some blocks if you can't see it immediately. So you can draw some blocks the same way we did here. Remember that this is our 6's place value. Okay, now that we're back, let's see if you get the same thing that I do. So if we add one more 1, well, we have 5, 2, 5, 3, and 5, 4. So there's no regrouping going on here. We have our 5 6's. We start with no 1s, then we add a 1, 1 1, 2 1s, 3 1s, 4 1s. Here, we're going to have to start regrouping a little bit. If we add a 1 here, we'll have 6 1s. But remember, whenever we get 6 of something, we regroup it to the next place value. So let me do just this one here so you can see the idea. So this is 2 6's and 5 1s. And if I add a 1, remember that what comes next, you just add 1. Now I have 6 1s. So I can regroup this to be 3 6's. Here's our 2 6's, and I'm regrouping these 6 1s to be that one. So I can write this now as 3 6's and no 1s. And that's the same thing as 18 in base 10. And then if we add some 1s, we get 3 1 and 3 2, all base 6. Okay, so the last one, well, we're going to have to do a little regrouping here. This is going to be very similar. We talked about the number 99 on the previous slide in base 10. Here we're talking about 5 5 in base 6. I don't like to say things like 55 in different bases. I just list the digits in the order they're in, just so it's not too confusing, because in the language we express numbers, there's a lot of base 10 stuff in there. So when I say 23 or something like that, 20 implies 2 10s. But I just want to say 5 5. So when I say 5 5 base 6, that's what I mean here. So what is this? So let's draw this out again. Maybe I'll do it all the way up here. So this is 5 sixes. Remember, each of these long pieces here have 6 ones in them, since we're in base 6. And we have 5 ones. If we add a 1, what do we get? Well, we can regroup those 6 ones into an extra 6. So now we have 6 sixes, but we have 6 of something. We have 6 of something. So we must regroup since we're in base 6. So we regroup that into one square. And the squares are made up of 6 sixes. So 1, 2, 3, 4, 5, 6 sixes. Each 6 is made up of 6 ones. So in total, there are 36 ones in our square block here. So if I add 1 and I do all the regrouping I need to do, I get the number 100, base 6. And really I should be putting little 6s down there just to say that we're in base 6. And if I add 1 to 100, well, I get 101. If I add 1, well, there's nothing to regroup. I'm okay. Base 6. And finally, if I add another 1, 102, well, still I don't have enough of anything to regroup, so I just leave them like this. This is 102, base 6. So let's talk about these numbers in expanded form. This one, I just wrote 3,215 in base 10 here, and then I wrote 3215 base 6. These are different numbers, and we'll talk about what this means a little bit in base 10 later. But we know how to write this in expanded form. We have 3 thousands, and I'm going to write it like this: 10 cubed. 10 times 10 times 10 is 1,000, right? And that makes sense with the cube, because here's our cube, and it's 10 by 10 by 10. So that cube is made up of 1,000 ones. So it's 10 cubed plus 2 hundreds. I'm going to write hundreds as 10 times 10, 10 squared. Then we have 1 10. I'm going to write 10 as 10 to the 1. And we have 5 ones, which I'm going to write as 10 to the 0. Anything to the 0 except 0 is 1, and that's just 1. So this is 3 thousands plus 2 hundreds plus 1 10 plus 5 ones. Remember, anything to the 0 here is 1. Okay. And the key to this, remember, this is a base 10 number. That's why the dimensions of all of our blocks here have to do with tens. If we're in base 6, our dimensions are going to be 6s. So 3215 in base 6, well, our blocks are going to be smaller. Our squares are no longer 10 by 10, they're going to be 6 by 6. Our cubes are no longer 1,000, 10 by 10 by 10, they're going to be 6 by 6 by 6. So this is going to be 3 times 6 cubed. So now our blocks are 6 by 6 by 6. Now let me actually move that. I don't like where that is. It's a little too close to the power. Maybe let's do it down here. So our squares now, our cubes are 6 by 6 by 6. And then we have 2 squares, and our squares are 6 by 6 because we're in base 6. We have one long piece, and a long piece is just made up of 6 ones. And we have 5 ones, of course, which is just 6 to the 0. And ones are just ones. So you can see what's going on. We can write an expanded form for a number in base 6 just by changing our dimension here. We have 6 by 6 by 6 for the cubes. This is the 6 cubes place instead of the thousands place, which is of course the 6 times 6 times 6 you can check is 216's place. And I'm using notation in base 10. So this is in base 10, this cube is made up of 216 ones. This is the 6 squareds place. Or the 36 place. And we talked about the other ones. This is the 6's place, and this is the 1's place. There are 36 ones in a 6 by 6 cubed, and there are 216 ones, or sorry, 6 by 6 square, not cube, and there are 216 ones in a 6 by 6 by 6 cube. And again, there's nothing particularly special about base 6. What about, maybe let's do base, I don't know, let's do base 3. So base 3. Well, let's count in base 3. It's going to look a little bit differently. So remember, anytime we have 3 of anything, we regroup. So in base 10, this is going to be our base 10. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll just do that. In base 3, well, I'm just going to write out the digits. If you don't see this, then it's a good idea to pause the video, see if you can draw it out with blocks like on the previous slide, and see if it starts to make sense with you that way. Remember, you want to regroup to the next place value when you have 3 of anything. So if we have nothing, we still have no ones. If we have one thing, we still have 1 1. 2 ones is still 2 ones. But if I add a 1 to 2 ones, I now have 3 ones. If I have 3 of something, I regroup. So I have 1 3 and 1 1. So 3 in base 10 is the same as 1 0 base 3. And I'm not going to write the subscript down here for the other ones, just in the interest of space. So the next one's going to be 1 3 and 1 1. That's 4. 5 is 1 3 and 2 ones. 6, well, if I add another 1, I can regroup again, so I have 2 3s and 0 1s. I'll just put a line here just to make sure we follow everything. 7 is 2 3s and 1 1. 8 is 2 3s and 2 1s. 9, well, we have to be careful. If we add another 1, well, then we have 3 1s, so we can make a 3 out of it, but then we would have 3 3s, so we can regroup that into 1 square, which has 9 blocks in it. So we write 9 in base 3 as 1 0 0. 1 9, 0 3s, 0 1s. 9 is 3 squared, so we have 1 square, 0 long pieces, and 0 1s. So 9 in base 3 is written 1 0 0. 10, let me put another block here, just so everything stays straight. 10 is 1 0 1. 11 is 1 0 2. And 12 is, if we add an extra 1, 1 1 0. I know it looks kind of weird, but remember, it's different because we're not regrouping when we have 10 things, like up here. If we add 1 to 9, then we have 10 ones, which we regroup into a 10, and then we have 0 ones left over. Here we regroup when we have 3 things. So I have 0, 1, 2. If I add 1 to 2, then I have 3 ones, which I can regroup into one long piece, 1, 3, and 0 ones left over. Hopefully that's starting to make sense a little bit. And of course the digits in base 3, I didn't write that. Oh, the digits are from the said 0, 1, and 2. So notice we never write down any digit in base 3 that isn't one of these things, 0, 1, and 2. We'll never write down the digit 3. In base 6, we never wrote down the digit 6. In base 10, we don't have a digit for 10, right? We only have a digit for 9. To express 10, we need to use 2 digits, and it's the same thing here. So we'll never write down anything other than these 3 digits, 0, 1, and 2. And we can express any number we like using those digits. There's one more base I want to show you. I'll do it on the next slide. Here's base 12. We'll deal with base 12 quite a bit in this course. It's a nice base to deal with. We're going to need 12 digits, which is kind of weird. Well, we know 10 of them we can use. So let's do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 digits. We need digits to represent 10 things and 11 things. Remember, we don't regroup until we have 12 things. So we need a digit to represent having 10 things. We can't write it as 1, 0 anymore because that's regrouping. So what's done in our textbook and in lots of other textbooks is they use A to represent 10 things. And we also need a digit for 11, so we usually use B to mean 11. And it looks kind of weird, but again, let's write out some counting with it. So let's do base 10. I'm not going to start at 0 this time. Let's start at maybe 8. So we'll go 8, 9, 10, 11, 12, 13, 14, 15, 16. That'll do. So for base 12, what does that look like? Well, 8 ones is still 8 ones. 9 ones is still 9 ones. But if we want 10 things, we can't write it as 1, 0 anymore. Remember, we can't regroup yet. We don't have 12 things. So if we add 1 to 9, we have 10 things, and we're using this digit A to represent 10 things. So I'm going to use the digit A. I can't use 2 digits because we can only regroup when we have 12 things. So this is 10 in base 12. 11 I can write as B. And now 12, if I add 1 to 11, now I can regroup. So this is going to become 1, 12, and 0 ones. So this is the 12s place. So I have one long piece that's made up of 12 ones and 0 ones past that. 13 in base 12 is 1, 1. 14 is 1, 2. 15 is 1, 3. 16 is 1, 4. All in base 12. It's kind of a weird idea to see. But the whole idea is that we can't regroup until we get 12 things. Where here, if I have 10 things, I already regroup them into one long piece. 11 is one long piece and one 1. And our long pieces are, of course, made up of 10 ones. But in base 12, I'm not allowed to regroup until I have 12 things. So I can't regroup my 10 things yet. I have to leave them as ones. So there are 10 ones. I can only regroup when I have 12 things. I don't have 12 yet. I'll do this guy down here because I already wrote there. So 11 looks like that. There are 11 ones. I can't regroup because I don't have 12. But once I add another one, if I add 1, then here it is down here. Now I have 12 things. So I can take these 12 and make them into one long piece. The base tells me how many I need to be able to group together to make the next piece in the place value. So 1, 0 base 12 is 1, 12, so that long piece is made up of 12 ones with no ones left over. 1, 1 is a 12 with 1 left over. Again, we did 6, we did 3, we did 12. You could do this with any base you like. You just pick the number of digits and you can build up numbers this way.